Hello students, how are you? कैसी तैयारी चल रही है? Welcome to my channel. If you have not subscribed my channel yet, please subscribe it. बहुत लोग चैनल देख रहे हैं लेकिन सब्सक्राइब नहीं कर रहे हैं. एटलीस्ट 62% लोग हैं जो कि सब्सक्राइब नहीं किए हैं लेकिन चैनल देख रहे हैं. प्लीज़ सब्सक्राइब द चैनल. Today I shall discuss about stoichiometry and stoichiometric calculations. In the chapter Basic Concept of Chemistry, I shall discuss about stoichiometric calculations. This is a very important topic in case of chemical reactions in order to calculate the amount of reactants or products. The word stoichiometry is derived from a Greek word which is formed by a Greek word stoichion, which means element, and metron, which means measurement. Therefore, in stoichiometric calculation, we discuss about calculation of masses or in some cases volumes of reactants or products involved in a chemical reaction. Thus, stoichiometric calculations deals with calculation of masses or volumes of reactants or products involved in a chemical reaction. Before studying how to calculate the amount of reactants required in a chemical reaction or products formed in a chemical reaction, let us study what information is obtained from a balanced chemical reaction. What informations we get from a balanced chemical reaction. Let us take the example of combustion of methane. The combustion of methane, CH4, this is methane. Combustion of methane in the presence of oxygen takes place according to the following chemical reaction. Here, methane reacts with oxygen to form carbon dioxide and water molecules. Methane and oxygen are called reactants. In this chemical reaction, methane and oxygen are reactants, where carbon dioxide and water are products. Carbon dioxide and water are products in this chemical reaction. Here, G represents the state of reactants and products. G is for gas. In this chemical reaction, reactants and products all are in gaseous state. In order to represent the gaseous state, the symbol G is used in a small bracket. In case of solid or liquid reactants or product, the symbol S or L is used. If the reactant is in solid state, then we use the symbol S. For liquid state, symbol L is used. Now, from this chemical reaction, we can see that the stoichiometric coefficient for oxygen is 2. Here the stoichiometric coefficient is 2, and also for water the stoichiometric coefficient is 2. It means that 2 molecules or 2 moles of oxygen reacts. Similarly, here 2 molecules or 2 moles of water is produced. The stoichiometric coefficient for methane is 1, and for carbon dioxide the stoichiometric coefficient is also 1. These numbers are called stoichiometric coefficient. This is a balanced chemical reaction. This information is obtained from a balanced chemical reaction. Now let us see what information is obtained from this chemical reaction? What information we can obtain from this chemical reaction? If we consider first is, if we consider the number of moles, then we can see that 1 mole of methane reacts with 2 mole of oxygen to produce 1 mole of carbon dioxide and 2 mole of water. In this chemical reaction, it is clear that 1 mole of methane reacts with 2 moles of oxygen to form 1 mole of carbon dioxide and 2 moles of water molecules in the product. Similarly, this reaction can also be interpreted in the form of number of molecules. Here, one molecule of methane reacts with 2 molecules of oxygen to form or to produce 1 molecule of carbon dioxide and 2 molecules of water. 2 molecules of water vapor are produced. Thus, we can also interpret this equation in terms of molecules. In case of reactants, methane. In case of reactants, 1 molecule of methane reacts with 2 molecules of oxygen to produce 1 molecule of carbon dioxide and 2 molecules of water vapor. The third interpretation of this balanced chemical reaction can be given in terms of volumes. We can also give this equation in terms of volumes. We know that at STP, standard temperature and pressure, 1 mole of gas occupies volume 22.7 liter. Therefore, 22.7 liter of methane reacts with 2 into 22.7 or 45.4 liters of oxygen to produce 22.7 liters of carbon dioxide and 45.4 liters of water vapor. Thus, this equation can also be understood in terms of volumes. Here, methane, 22.7 liter of methane reacts with 45.4 liter of oxygen to produce 22.7 liter of carbon dioxide and 45.4 liter of water vapor. In the last case, this equation can also be interpreted in terms of masses, in grams. 1 mole of, we know that 1 mole of methane is equivalent to its molar mass, which is 16 gram. Therefore, 16 gram of methane reacts with, in case of oxygen, it is 2 into 18, which is 36 gram. 16 gram of methane reacts with 36 gram of oxygen to produce 44 gram of carbon dioxide and 2 into 18 with 36 gram of water vapors. So this equation can also be given in terms of masses in grams. Here methane has molecular mass 16 gram. Therefore 16 gram of methane reacts with 2 into 18, that is 36 gram of oxygen to produce 44 gram of carbon dioxide and 36 gram of water. Thus, we see that from the stoichiometry of this reaction, we can calculate the amount of reactants required or products formed in a chemical reaction, either in terms of number of moles or in terms of number of molecules or in terms of volumes or in terms of masses. Therefore, we can say that from stoichiometry we can interrelate the moles with number of molecules, and this is also with mass, molecular mass. Mass can be converted into number of moles and moles can be converted into molecules. Thus, these three things can be interrelated from the stoichiometry of this reaction. So, I have discussed about stoichiometry and stoichiometric calculations. The stoichiometry deals with calculation of masses or volumes of reactants and products involved in a particular chemical reaction. I have taken the example of combustion of methane, in which combustion of methane takes place. Methane combines with two molecules of oxygen to produce one molecule of carbon dioxide and two molecules of water vapors are formed. In order to clear this topic, let us take some examples how to calculate the amounts of reactants or products involved in a chemical reaction. Let us take first example. Calculate the amount. Calculate the amount of methane required to produce 18 gram of water. Calculate the amount of methane required to produce 18 gram of water. So, first we write the balanced chemical reaction for the combustion of methane. The balanced chemical reaction is CH4 plus 2O2, which gives CO2 plus 2H2. Now, from the stoichiometry, we can see that in case of methane, 16 gram of methane produces 2 into 18, that is 36 gram of water. From the stoichiometry of balanced chemical reaction, we can see that 16 gram of methane produces 36 gram of methane. Therefore, 36 gram of water is produced from 16 gram of methane. Therefore, 1 gram will be produced by 16 upon 36. Here, the amount of water given is 18 gram. Therefore, 18 gram of water will be produced from 16 into 18 upon 36. After simplification, we get 8 gram CH4 methane. Thus, we see that 8 gram of methane will be required to produce 18 gram of water vapors. This calculation has been done on the basis of stoichiometry of this reaction. Let us take another example. Calculate the number of moles. Calculate the number of moles of methane required to produce 22 grams of carbon dioxide. The problem is calculate the number of moles of methane required to produce 22 grams of carbon dioxide. We have to calculate the amount of methane in terms of moles, but the amount of carbon dioxide has been given in terms of grams. Solution. First of all, write the balanced chemical reaction for the combustion of methane. The combustion of methane takes place according to the following chemical reaction. All the reactants and products are in gaseous state. Here, 1 mole of methane reacts with 2 moles of oxygen to produce 1 mole of carbon dioxide and 2 moles of water vapor. 1 mole of methane gives 1 mole of CO2. This thing can also be written in terms of grams. Methane has molecular mass 16, therefore 16 grams of methane is required to produce 44 grams of carbon dioxide. Thus, we can see that since 44 grams of CO2 is produced from 16 grams of methane, therefore 22 grams of carbon dioxide will be produced from 16 upon 44 into 22. It is 8 grams of methane. 8 grams of methane number, but we have to give the number of moles of methane. We know that 16 grams is equivalent to 16 gram methane is equivalent to 1 mole. Therefore, 8 gram of methane will be equivalent to 1 by 2 mole or 0.5 mole. 0.5 mole methane. This is the answer. Thus, the number of moles of methane required to produce 22 grams of CO2 is 0.5 mole. Thus, we see that 0.5 moles of methane are required to produce 22 grams of carbon dioxide in the combustion of methane. Thus, with the help of stoichiometry, we can calculate the amount of reactants or products required in a balanced chemical reaction. So, today I have discussed about stoichiometry and stoichiometric calculations. I have taken the example of combustion of methane and also solved few examples. Hello students, today the next topic is limiting reagent. Many a times chemical reactions are carried out in which reactants are not present as required in balanced chemical reaction. Some reactant is present in excess, however, another reactant may be present in lesser amount. The reactant which is present in lesser amount get consumed first, and therefore further chemical reaction does not take place. However, amount of the another reactant may be present in the reaction mixture. Thus, the limiting reagent may be defined as the reactant which gets consumed first and limits the amount of product formed in the chemical reaction. Let us take one example in order to clear the concept of limiting reagent. Let us take the combustion of methane. Let us take the example of combustion of methane. Combustion of methane, the balanced chemical reaction is CH4 plus 2O2 CO2 plus 2H2. Here 1 mole of methane reacts with 2 mole of oxygen to produce 1 mole of carbon dioxide and 2 moles of water vapor. From stoichiometric calculation, it is clear that 16 gram of methane reacts with 36 gram of oxygen to produce 44 gram of carbon dioxide and 36 gram of water vapor. Let us take the case when 8 gram of methane is mixed with 36 gram of oxygen. Now, from stoichiometry, we know that 16 gram of methane reacts with 36 gram of oxygen to produce 44 gram of CO2 and 36 gram of water. Thus, 8 gram of methane will react only with 18 gram of oxygen to produce 22 gram of carbon dioxide and 18 gram of water vapor. Thus, here methane is present in lesser amount and it gets consumed first, and it limits the amount of product formed in the chemical reaction. Therefore, here methane is called limiting reagent. Here another reactant, oxygen is present in excess amount. 18 gram of oxygen is present in the reaction mixture, but the further reaction will not take place since another reactant is consumed. So here methane is limiting reagent. So today I have discussed about limiting reagent and stoichiometric calculation. Thank you for watching my channel. Please subscribe the channel if you have not subscribed yet. If you have any query in this lecture, you can write in the comment box of this video. Thank you once again.